Good morning, afternoon, evening. We are from Group 10 that has two members, Helena and Keisha. In this video, we will present our research paper about the importance of big data preparation in microbial colony classification. This paper was submitted to the International Conference of Informatics, Multimedia, Cyber, and Information System 2024. Next. Microbe is a microscopic organism that has been used in various industrial and medical processes. Unfortunately, microorganisms can also cause various diseases that are detrimental to humans. It is estimated that there are around 1,400 types of pathogens that have the potential to induce disease in humans. After we researched the importance of data preparation and a CNN model, Inception V3, our results have reached accuracy of 94%, with macro average precision of 95%, recall 96%, and F1 score 95%. We have also reached weighted average precision of 95%, recall 94%, and F1 score 94%. In conclusion, we gain proofs that even with the small number of images, which range from various widths, shapes, colors, and size, can still provide correct classification results to 89% accuracy. Next. This presentation has 7 points that we will highlight, that are the introduction, the problem, literary review, the objectives, methodology, results, and conclusion. Next. For the introduction, microorganisms can be utilized for various types of needs, like medicine or biotechnology fields, but also can cause various types of disease due to bacteria and virus. Classification of microorganisms is needed to determine and map which microorganisms that are harmful or useful for humans. Next. Our paper has two problems that will be discussed and researched about. First problem is about the large and multidimensional dataset that need to be processed. And the second problem is about conventional methods, like plate counting methods that is time-consuming. Next. We did some literature review and searched many papers that are relevant to our topic. The insight that we got from literature review are from the large number of datasets. We need to perform big data processing to handle various problems in the data in order to produce accurate and efficient classification. Also, in the previous work, some architecture models from CNN method were compared, and we did some review to choose the method that we use for this research. Next. The objective of our paper are to collect reference datasets and implement data preparation so that the machine can learn how to recognize new data samples more quickly and accurately. And the processed data will be used in the classification process using the CNN method to perform well and high accuracy.
Okay, next I'm going to explain about our workflow. The image below is the workflow of our CNN method, and the method that we use are CNN Inception V3 architecture. The dataset that we use are microorganism pre-processed image from dataset from Kaggle. Inside there, we already have images from varying label, from yeast images, amoeba images, hydra, spiral, spherical, rod, bacteria, and Euglena images, also with Parsemium images. Now, I'm going to explain briefly about our methodology. The first step is that we have data storage, so it contains every classes. Then we have image preprocessing, then to make sure that our data is able to be processed by our model, and we also divide our dataset into three parts: training, validation, and testing. During the training process, model performance is evaluated using various metrics, and after we evaluate our training process, we will search for the model evaluation and plot results, where the final model is evaluated using accuracy, precision, and recall. Next, I'm going to explain briefly regarding the image preprocessing method. In the image preprocessing method, the reason why we do preprocessing image is because the preprocessed image before loading into a model is a fundamental aspect of any machine learning project, particularly for tasks like image classification with convolutional neural network. It's common to preprocess image by converting them into standard format, such as RGB, and we do noise reduction as a part of image preprocessing. Then we use TensorFlow and sklearn to encode our image into simple numerical encoding, such as one-hot encoding, and to convert the labels. After we do image preprocessing, next we will do model evaluation. I'm gonna explain briefly about our model preparation. In our model preparation, we train our images from convolutional neural network for for image classification, and the next step is to provide the outline and iterative process of updating the network weights over multiple epochs until a predefined stopping criterion in is met. In this experiment, we also load our base model, which is Inception v3, where after we prepare our model, we create additional model on top of the base model by adding global average pooling to reduce the dimensionality of the feature maps. Once the model is already prepared, we do early stopping to maximize the model performance, and we add learning rate reducer. Lastly, we add cross-validation to evaluate the model to provide comprehensive assessment of the model evaluation. In the presentation, it's a brief description regarding our convolutional neural network of Inception V3. Next, I'm going to explain the results. Considering using Inception V3 model, with our limited datasets of 800 image, we're able to reach the staggering amounts of validation accuracy of 0.9438942556381123. Or we count it down as 94.3% from the fifth and fold and 89 average accuracy from every folds with the right method of data preprocessing. We have tested and trained the model to reduce the value loss and increase the accuracy so it can reach the optimal performance. Next is the results. Here are the plot for model accuracy and our model loss. From the image above, we can conclude that as the training got higher, the testing is set to placid into gradual decrease of 0.89 accuracy on the last epoch. The loss value has also gradually decreased on training set while the testing set has reached 0.35 loss. The model training accuracy indicates good convergence, which suggests that the model has learned as much as it could from the training data. In conclusion, preprocessing datasets used in a big data has huge impact on how the data will be performed using CNN model. With the correct preprocessing handling method and model preparation, the result that we gain proves that even with the small amount of image, which range from various widths, shape, color, and size, we can still provide correct classification results to a 89% accuracy, though we're still limited in the amount and quality of images as the range of image varies between one organism to another, causing a huge amount of method and result being scrapped. Hopefully, with the rise of CNN and image preprocessing, high-quality microorganism dataset can be provided in the future. That's it for our presentation. Thank you.